This is this is a series of videos, where I call it Coding with Sally, where Sally and I start, talking about programming in general. Sally is very interested in writing software and learning about software, and I kind of asked Sally if she would be so generous to allow me to kind of publish these videos and put them out there and put our content out there. So a lot of people out there who are just really new to the software industry and really want to actually learn how to, build software from scratch. I want these people to kind of, look at these videos and hopefully ask questions. This series is about programming in general, software engineering in general, but we're going to be using C# as a way to materialize our thoughts, to kind of put, what we're saying, our theory into action, kind of put the form and the function together and actually be able to kind of, put something out there for people to actually benefit from. If you are watching this video and you don't have much experience in software engineering in general or in C#, I really highly recommend you follow that series. I'm going to produce, a video in this series as much as I can. The plan here is about 30 minutes or an hour every day, every weekday, and as much as we can. And Sally seems like if she's very, very curious and she wants to learn about, our industry, and but also at the same time, just feel free to reach out through the video. And if you know someone who would benefit from these videos, please share it. These videos, my YouTube channel is unmonetized. You won't see ads or any of that stuff. This is just, me showing you, how to build software as much as I can, kind of my way of giving back to the world and just, kind of helping everybody learn from this, and hopefully that, they can benefit from it. So this is my series. I call it Coding with Sally. And this series here is basically we're going to talk about programming, we're going to talk about engineering in general, and how can we build, systems that are beneficial, something that can help us. Everything today is engaged, with technology. You wake up in the morning, the first thing you look at is your mobile phone. Whether it's a good thing or a bad thing, that's a story for another day. But, all your systems, your healthcare system, your banking, your schooling record, you go to job, everything is running with software. And I am here with Sally to demystify software for people who are just trying to kind of scratch the surface in this world. What is software is like? What's it take to be a software engineer? How do you build software? Do I need to know math? Do I need to be an astronaut? Do I need to know physics? I mean, Sally has a PhD degree, but I promise you, you don't have to have a PhD degree to be a software engineer. You just need to be really good with logic, and that's pretty much it. So without any further ado, I'm just going to start here to talk about, why do you need to learn software? Why do you need to know to learn programming? What do you benefit from when you learn programming? A while back, people used to use math to basically express problems and kind of simulate these problems in terms of equations, and then try to solve these problems on paper through equations. That's how people were able to, if people started with philosophy, and then applied philosophy became mathematics, and then applied mathematics became physics, and then applied physics, it kept just growing into that direction. And today we express all of our thoughts through code. So when you write code, you're basically trying to resemble something in the real world and trying to solve a problem. I'll give you a little example of this. So let's just say you bought this new house, right? And you have your house, and this is the space of your house. This is my space. Let's say this is your plan of your house. And let's say you have a bathroom in here. Let's say you have a bedroom over here. So this is here's a bathroom, and maybe there's a bedroom over here. And maybe you have a living room, in the middle here. And this is maybe the entrance of your house and all that kind of good stuff. Now, what could software do for you to help you kind of furnish this house? You want to put in tables, you want to put in chairs, you want to put in bunch of stuff, right? This is a problem. The problem here is that you want to be able to, without having to do too much work, you want to be able to go and say, well, I want a, I want a bed, I want a sofa, and I want a dining table, for instance. And I want to be able to have a software being able to help me select the kind of furniture that will fit into my house, right? So that's a simple problem here. You have the width, you have the height, you have the length, you have all of these little parameters in your house. So you have all of these little details. And your job is to extract these details, about your house, and also give the software the ability to learn about what you're really trying to do with that house. What kind of furniture you want to furnish your house with, and the software will be able to tell you whether you will be able to furnish your house with this particular furniture or not. What do you think about that, Sal? Is that simple? That's very simple, right?
That's good.
Okay. All right. So let's say, for instance, so this is a problem we're trying to solve. You're basically, I'll come to that point in a second, something that we call modeling and simulation. If I were to summarize the engineering, industry in general, or the practice of software engineering, it's really nothing but modeling and simulation. You're basically picking up objects like chairs, I don't know, whatever the case may be. Here's a chair. Why is it upside down? I don't know. That's weird. Is it upside down? I think it's upside down. So here's a chair, right? I think that, oh, it's just a chair from the top. That's what it is. Oh my God, that's a terrible. Anyway, so you have a chair like this. So here's a chair, and then maybe you have, I don't know, maybe I don't know, any other furniture, whatever the case may be. Let's say Xbox or something. Here, I'm gonna put in like a gaming system into the house. You want a gaming system? Maybe you want a TV, so I'm just gonna put in a TV in here. Let's see if we can find a TV. So here's a TV. There's a lot of TVs. Here's another. Here's a TV from the top. Nice. There you go. I want to put a TV here. Okay, maybe this Xbox is kind of silly, but here's a TV and here's a chair, and I want to put the chair in front of the TV, and I want to make sure that in my living room, putting the chair and the TV in that living room will basically be able to fit within that kind of room. So I'm gonna push that to the back, and then push that again to the back, and here we go. Here's my living room right here. A chair and a TV. What can software do for me here? Well, if the problem that you're trying to solve is just a problem of space, of size, then it's really important that you extract the things that you care about and let go of the things that you don't care about. So let me ask you this, Sally. A chair could have so many attributes, right? It could have a height, a length, a width, a weight. A chair could have a color. It could have a price. It could have a model. It could have so many different attributes. Let's put these attributes in here. So let's say this is your chair. This is the chair that we're having in here. This is a chair, and uh, this chair here has, let's say, all these different attributes. I'm gonna throw a bunch of attributes around here, and let's say, so maybe it has a size, but it also has a color, and maybe it has a price, and it has a model. In a problem where you're trying to solve for whether that chair would fit into your apartment or not, what are the attributes that we should care about in here in terms of finding out whether that chair fits or not, um, in terms of a problem solving? So we have all these attributes, and that's our model in here. So what should we care about in here?
The size.
The size. That's the only thing that I care about. So this is one attribute that I care about, and everything else you can drop in the trash because we don't really care about. And that's what we call something that's really nice, that we call modeling, meaning that you're looking at an object in the real world, in the real life, and you're basically going and saying, okay, for this object, I want to go and say, to solve a particular problem, I don't really care about, because Sally, there are infinite number of attributes into every single object around us. You can extract information for days. As this simple cup of tea that I'm, holding in my hand right now, it has so many different attributes. It has a temperature, it has a size, a weight, it has a price, a color. It has so many different things. The engineering here comes into play when you try to extract the attributes that only matter to solving your problem. Okay, so engineers, they go and say, I have a problem, and I'm going to simulate this chair here. And the way how I'm going to solve this problem to see if that chair fits in or not, then I need to care about the size. Okay, so I have a chair. Let's just say I got that chair in here. Let's throw all of this away. So the size of the chair is what matters to me, and that's the attribute that I'm going to care about. Okay. What else do we need to simulate in this location here, Sally, so we can figure out whether a chair would fit into this room or not?
Size of the room
The room.
With TV, that other item.
And the other items. So basically we have this and we have this and we have a room size and we have a TV size and each and every one of those have their own size and all that kind of good stuff. And we're going to kind of get a little bit, kind of build on top of that problem as we go. So this is all I care about. I want to know what the objects are in my place.
Also, you want to figure out like this is the only two item, or still you want to add, or you
There you go.
Mhm.
So it sounds to me like we need to be able to build a program. And this program will be able to take furniture like this, and it will be able to tell me every time I try to add another piece of furniture, whether I am allowed to add it in or not. And then we can add a little bit of intelligence on top of it later. Okay. Now, don't worry. Like I said, whether you know programming or not, it doesn't matter. I'm going to open up a little software here that engineers use called Visual Studio. It's basically an integrated development environment. We call it an IDE. And this integrated development environment basically helps the engineers kind of write software, to be able to kind of solve these kind of problems. Like if you're watching this video, we're solving a problem for placing furniture in a room. Believe it or not, people try to use software to solve major problems like, climate disasters, cancer, COVID, any of these issues that we have in our world. The bigger the problem, the more complex the program will be. And that's the power of software. The power of software today is to be able to kind of, help you solve problems that it would be a little bit harder for you to solve, manually, just on a piece of paper. So, okay, I'm just going to start a new project here. I'm using Visual Studio 2022 on a Windows operating system. You can also run, Visual Studio on a Mac machine. Sally uses Mac. She's going to be using it and showing us some of the code that we work with, as we go. But, for the time being, I'm using a Visual Studio 2022. So, okay, so I'm just going to go ahead in here. I'm just going to start a new project, and I'm going to call it, space solver. This is solving a space problem. I have a space issue with adding furniture, and I'm just going to call my program something that best fits, whatever problem I am trying to solve. Okay. Sally, tell me if you can see my screen now. Is it
No.
visible? All right, perfect. Okay, so this is a new program. I'm just going to delete everything in here. I'm just going to start really, really from scratch. Okay. Okay. So we said there's a chair, there's a room, and there's a TV. When we go and model things, when you say model in programming and software engineering, that automatically means you're building a prototype of this object that you're trying to model in the real world. And building that prototype is what we call classes. So I can go up in here and say public class room. Boom, I basically built a prototype for a room. Now, that room, like you said, Sally, that room has a size, right? So let's just say I put a size in here as a number, and I'm just going to say this is the size of this room. We're going to keep it really simple, and then we're going to talk about heights and width. And what do you think about that? Does that seem simple? I basically built a model, which is a class, and this model has an attribute on it. And this is just a prototype. What that basically means, it means that this is just a description of what a room would be like, but you can materialize that description as much as you can. Like you can go in here and say, bedroom, like this is a room. And you can go here and say var living room is also a room like this. You can materialize this however you want. You can create as many instances of a room based on that particular prototype. Is that clear? Any questions here?
I have a question about this. I don't know about this war or those, but I got the idea. Like based on that room, you can have like different categories, and then you can expand that basically.
Exactly. And var is just a shorthand way of going and saying, hey, since the right side is known, you can also go and do this room, like that. So this is a room.
Mm-hmm.
So this is a bedroom, room type, and we're creating a new instance
Mm-hmm.
of that prototype. This one is really, really important. So I'm telling you, I've been doing this for 20 something years, and up until today, we still write our software exactly the same way. So this is not just academic or theoretical. This is the real deal. This is the real stuff that we're doing. Okay. So what else do I have other than the room? We said that we have, I don't know, did you say chair? And the chair also has a size. Here we go, size, like this. What else do we have? We also have a TV.
Mm-hmm.
TV, just like, sorry, yep, size. There it is. So each
How
one of, go ahead, go
like,
ahead.
can we have like room and then items? And then items can have different like chair, TV, and each one has size, right? Or
Of
each.
course.
Okay.
Of course. We can do that. We can create something. I'll get to that point in a second. Just give me 1 sec. So okay, so this is you're just jumping ahead, but that's good. That's a good thing. So I created a room and I created a chair and I created a TV. What I'm basically noticing in here, let's just try to solve the problem first. So I created these different, models. I'm going to zoom out a little bit just so people can see. Let's go in here and say, I'm going to create a little function in here, a simple function. And this function here will tell me, Boolean basically means whether um, uh, the item that I'm trying to add into my room, whether it fits or not,
Mm-hmm.
whether this item fits or not. So I'm gonna go here and say, does item fit? So the function will return a Boolean expression. It will go and say yes or no. So bool here meaning yes or no, true or false. And then I want to pass this item in there. Here I'm running into a problem. What's the problem? Is that I want to be able to pass in as many items as I want, but I can't pass in a TV and a chair in here because I have to define some sort of a type that includes all of them. So how about I create something in here that I call public class furniture, whatever that furniture is. And then this furniture will have a size. And then instead of writing this code over and over again for every single piece of furniture that I have, why don't I just remove all of this and just go and say a chair is a furniture and a TV is a furniture, like this. And now my function can go and say, instead of adding specifically a chair or a TV, why don't you just add any piece of furniture, let it be a TV or a chair or anything in the future, without having to worry about, whether this is working or not. What do you think about that idea?
Yes,
So
got it. Got it.
yeah.
Mm-hmm.
Okay. And that basically means I don't have to type that size over and over again. If this property or if this attribute is shared across all, then it may as well be a part of this whole, of each and every instance. Now, let's say maybe we want to add something specific to the chair, something like a color, for instance, that will be specific to the chair. So the chair will have both this attribute and this attribute without any issues. But then the TV will not have this color. The TV will have the size. What do you think about that? Does that make sense?
Yeah. Inherit some of them from the like basically main class
Parent
and
class, yes.
something added to that. Okay.
Precisely, precisely. Okay, so we're just trying to write a program that will help us kind of, understand, whether we can add in more chairs into a room or add in more TVs into a room or not. That's really all that we're doing in here. Okay, let's see if we can fix some of that stuff in here. I'll talk a little bit about the new styling for C# and all that kind of stuff. Let me just get a very simple, let's see here. What is it trying to do? Expression. Let's create a namespace using solver is my namespace. And I'll tell you in a second what namespace is. And then inside that namespace, I want to create a class and I'm going to call it, you know, the space solver class. So that's the program that I'm writing. This is where everything is going to happen. And then inside that space solver, I'm just going to go ahead and do something just as simple as going and saying, you know, here's a function, right? And does furniture fit, right? And I'm going to go in here and pass in a furniture in here. And I also want to pass in the room, right, Sally? Because I need to tell the program which room I want to fit that furniture in. What do you think about that?
Got that. Basically, two arguments.
Two arguments, right? And then all I have to do is just go and say, well, you know, this room here, what's the size of this room? And what's the size of this furniture? And whether the size of the furniture is bigger or smaller or equal to the room. That's all I have to do. So it's really just logic. I want to go and say if this piece of furniture, that size, the size of this piece of furniture, if it's less than or equal the size of the room, then go ahead and return this size. This guy fits. Like this little piece of furniture will fit here. Otherwise, return false, which basically means, oh, you know, that piece of furniture does not fit into this room. What do you think about that?
Oh, okay, yeah, I got it.
Very straightforward, right? I can just go like this and say, you know, this is my program and this is how I'm going to do this. And I just want to see if my furniture fits or not. Okay. Okay. So this is a function that does something for me. This is a program that will take in the furniture and the room and tell me whether something fits in or not. Okay. Let's write something that would actually run this code. In C#, there's something called the main class or the main method. And that main method is basically what gets things running, what gets things to execute, basically. So I'm going to write a main method in here, public static void main. It takes in, we will talk a little bit about all the details of this main method here, but you know, for short, this is the method that I'm going to use to run my program. And then let's just visualize, you know, based on these prototypes that we've created, let's just start drawing the world that we just talked about. So I have a room. Here's my room. And let's just say my room size is 1,000 feet. That's a lot, right? That's a lot for a room. Maybe 300. What do you think? 300 is good, right? And let's say I have a chair. Let's say, I don't know, this is a racer chair, cool chair. This is a new chair that I just created. And this chair here, racer chair, has a size of, I don't know, 20, whatever that is. And maybe we have a TV as well. So this is my, you know, I don't know, LG TV, you know, here's a TV. And this LG TV size, let's say this TV size, I don't know, maybe 10. So let's go back to the picture that I was drawing earlier. This is how I basically picked up something like this and I turned it into code. Let me copy that code in here just so people can understand. Let me go over back into this here. Here's my code. So this is really all I did. I basically simulated, modeled and simulated the world that I'm trying to solve a problem in. Now, all I really have to do is to basically call this function and ask this function whether my chair would fit in the room, whether the TV will fit in the room or not.
Can you please go back to the function again?
Yeah.
I have a question here. So basically, when you say if a statement, so it check for single item.
Yes. Yeah.
Not the combination, right?
Yes. 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 For now, it's just checking one single item.
Okay.
We're gonna evolve this function a lot, right? Okay.
Yeah.
So now I'm just, the answers. I want to print out. I'm gonna go here and say write line and just tell me, I'm gonna create a little variable in here. I'm gonna call it does furniture fit? That's the answer to my question. And then I'm gonna call my function here. And I think my function needs to be static because the function itself, the main function itself is a static, so you can't actually call a static function from non-static. So, okay, so does furniture fit? And let's just see if the racer chair, would the racer chair fit into my room? That's really all I'm asking for. Right? And then we're gonna print out that answer. Right? The racer, the furniture fitting is, and I'm gonna put the answer in here. Let's run this program, Sally. What do you think about that? Let's run this program and let's see if we can run this program real quick. I'm just gonna go back here and say .NET space solver project solver like this. What is it saying? Possible reasons built in. Let's see. I could not execute because a specified command or file was not. Let's see. Probably doesn't like. Is that project? Okay, I'll just run it from the command line. Sometimes I forget the. Okay, fine. Let me run this here. I'm just gonna run it from the command line and share the screen with you. We're gonna evolve this program a lot. So look at this. I'm running it from the command line here, and I basically this is the result. Can you see this guy? It's
Yeah.
so it's basically saying the furniture fitting is true. And it's saying it's true because the chair that's going into this room has a size that's less than the room itself. Sorry, less than the size of the room itself. That's very clear, right? Any questions about that one?
No, I got that.
Perfect. Let's go back to this guy here. And let's make things a little bit more complicated. What do you think about that, Sally? We want to add a bunch of furnitures. And we want to see if this bunch of furniture that we're adding in would fit into this room or not. This is where things get interesting. There is something in programming that's called params. Params like this. And this params basically goes and says, I want to add as many pieces of furniture into this room like this. Let me take this one out and put the room out here like this. Yeah. So this params here, it's basically saying, I want to add all the furniture into this room, and I want to know whether this furniture that I added in fits or not. So how are we going to do that? We're going to change things here a little bit, Sally. We want to go and say, well, every time we want to first go and say, define a variable here that's called available space. And this available space starts by the size of the room. So this is what's available, is the size of the room. But I'm gonna go and iterate for each piece of furniture, right? So for each piece of furniture that I have in here, furnitures, in these furnitures that I have in here, so this is furnitures like this, for each one of those, each single furniture in these furnitures, I want to go and say, okay, go ahead and if, right, the furniture, the one piece of furniture, that size is less than or equal available space. If it does, then go ahead and subtract the size of that piece of furniture from the overall size of the room. So the available space gets a little bit less. So it becomes the available space minus the furniture dot size, right? Like this. What do you think about this equation?
Okay, I got the logic. Available space minus furniture. Okay.
So I'm basically saying every time, so I passed in a whole bunch of furniture in here, and I'm basically going and saying, for every piece of furniture, go and iterate, check each and every one of them. That's one of the powers of programming, is to go and say, I want to be able to iterate and iterate and iterate. So what I'm basically, go ahead.
What I'm thinking is still like how the way we write down the class like furniture, then the item inside the furniture. So this is still I'm trying to find like this is the class, new class you call it, new basically object of the furniture. This is kind of not clear.
Okay. So so basically you're trying to find out what does it mean a new object of this, right? Okay. Think about this. Let me ask you this. We are all humans, right? We're all human beings. It just so happens that you are an instance of a human that's called Sally, and I am an instance of a human that's called Hassan.
I got it. Okay.
So this guy is the prototype,
You
or
named
a
it?
type, really. Go ahead.
Yeah, you call it the type first and then the name of the variable, right?
Exactly.
Okay,
Exactly.
gotcha. So, okay, I got that.
Basically, when we are born, we're basically instantiated. So a human, Hassan, equal new human. There's a baby right there. Now that's a baby right there. Because you basically went and said, I need a new human.
Yeah.
Right? But you can't really, like the instance itself is not a type. It's of type, but it's not a type in and of itself. What do you
So,
think?
but here you define the object, like basically define the Hassan as a human, but up over there up, so like single furniture. So it's not basically you didn't define it as a new object yet, right?
The furniture? Oh, you mean in the inputs in here?
Yes, when we write down the for each, it's a furniture.
Oh, yeah. This is basically going and saying, hey, for every item in here, give me one of it. Like that list, this is a list, basically, an array, right? I'm basically going and saying, from every item in this furniture, give me one and let me examine it. And this one that I'm taking, it's of type furniture. So I'm just defining what type
Okay.
I am actually extracting out of this. You'll see in some programming languages, they even lose this one. They say, let me iterate over each and every one of those. And that's really the beauty of programming, because if you look, let me write something real quick in here for you, so you just see this. I really want you to understand iteration, because that's one of the most powerful things about programming. If I can simplify programming for you, it's either sequencing or iteration or selection, and we're going to talk about each and every one of those. But let's just say it's just something as simple as this. I can go like this and say, for each number starting from 0 in 10 numbers, so from 0 to 10, right? Like this. Go ahead and add a new number and just print out this number for me. Just these 3 lines have saved me typing the exact same command for 10 times. If I go and execute like this, look what it's going to do. Just prints all the numbers for me. That's where engineering or programming in general shows you its true power, is that with only 3 lines of code, like imagine if I wrote here 100, how about 1,000? How about 1,000,000? It will take care of iterating and executing the exact same routine over and over and over again without you having to do that much effort, doing less and accomplishing more, basically.
Good.
Okay, let's go back to this guy. So this is basically what this means. It basically means, hey, I want to go and iterate for each piece of furniture in the furnitures that you passed in. Let's go ahead and examine the space. Now, what happens if the piece of furniture size is no longer less than or equal to the available space? What should we say, Sally? What should we do here?
False, it doesn't fit, something like that.
It doesn't fit. It doesn't fit. And how do we express that in a Boolean value?
Mm, ball
We could.
is false, so basically
Yep. Thank you so much. That's it.
return false. Mm-hmm.
Yeah, you're going and saying sorry, it's false. Now here's a question for you. What if we iterated and iterated and iterated and we never hit that guy and we exited this iteration, like we examined against all the available space and
Mm-hmm.
then everything, look at this thing is giving you the answer. This new AI thing is giving you the answer. But you know, we iterated and finished iterating over everything and we still have available space. What should we say?
Maybe we can kind of inform that we have a space or
Yep. So
mm-hmm.
that means all these items that we passed in will fit into this room.
Mm-hmm.
That's it. That's the problem we're trying to solve. I want to give my room a bunch of pieces of furniture, and I want this program, this really simple program that we wrote here. See, it's logic. Go over every piece of furniture. If you still have space, then subtract from that space so we can account for the next one, right? And if you don't have space anymore, go ahead and say, sorry, this is not going to fit. Let's
Mm-hmm.
try it out. What do you think about that? Look how our program is going to change now. So you know how we had a room and a racer chair and an LG TV?
Mm-hmm.
Now I'm going to go take that room and put it in here. This is my room. And then I'm going to start going and saying, okay, all this furniture that I have, I'm going to pass it in here to the LG TV. Let's add in a bunch of other things, right? Let's add in more chairs, right? Like maybe chair, kitchen chair. I want to put the kitchen chair. I want to invite my friends over. Right, I'm gonna add a kitchen chair in here. So this is a kitchen chair here, kitchen chair. Okay, here we go. Kitchen chair dot size equal, let's say maybe 20, right? And so this is all the furniture that I have. So look, I can add this furniture in here. I can add it forever, as much as I want. Look, I can keep adding and adding and adding. So here's the room and here's all the furniture, right? What do you think? Let's try it. Let's see how it works. It's really bothering me that it's not executing. So I'm sorry, Sal. I'm gonna have to try it again. .NET space. Give me a second. Hold on. Really bothering me. Let's see. Okay, .NET run project. Come on. And I want to add in that space solver in there. What's this? What did I get? Look at this. It's saying something in here. What is it saying? It's saying not all code paths return a value. So it's sad. Something is making it sad. Oh, did I forget to build? Oh, I'm sorry. I need to build. Hold on. Let's do this again. Okay, let's try this again. I'm going to clear all of this junk. And I'm going to run my program again. Okay, could not execute because specified command, whatever. Okay, let me. Oh, .NET run, sorry. Okay. Not valid project file. Okay. See, I'm really stubborn. I really want it to work.
Why you call it a space solver rather than because the class was a space solver? Do
Yeah,
you run
almost
it
there.
like a solver or a space
No,
solver?
no, no. Here it is. Here it is. Look.
Oh, okay, now it's kind
Yep.
different. Settings.
Yep. It's just I always forget this command, but here it is. .NET run project space solver, and
Mm-hmm.
then I went and I said, hey, here's the space solver,
Mm-hmm.
and then the furniture fitting is true. Now let's go ahead and have it say false. Let's add something terrible, something huge. Let's add in, I don't know, public class, something like what do you call it? The bounce house or something like that, right? And that's just like something that's really huge. So this is furniture like this, and this bouncy castle or bouncy castle here, bouncy castle. Can't put a bouncy castle in front of a room. I'm gonna go and put a bouncy castle in here,
Mm-hmm.
right? And it's gonna have the size of a 500, Sally. Size 500. And then I'm gonna add this bouncy castle in here.
Mm-hmm.
And let's run our program again and see what happens. See what happened? False. Why? Because the furniture that I'm trying to fit into this room doesn't fit.
Mm-hmm. One thing I have question. So you know that you wrote down the message here after
Mhm.
this Boolean. Can you put it back up in the you know the place that should return false or return
Oh, in here?
yeah.
Yeah, absolutely.
That we change the bool message like the output to the string, and then here change it to the message.
Mhm.
We
So
will
you
get.
want this to be a string? Yeah, we can go like this and go and say, here's a string,
And
right?
then,
And we can go up in here and say, you know, here is return
mhm.
furniture doesn't fit.
Yeah.
Right.
Then we don't kind of save that line. Yep.
Of course. And then here say furniture
Mhm.
fits like this.
Mhm.
Yeah. But now what are we gonna change? We're gonna have to change this guy to what?
Go to the string.
String. And maybe we need to throw, you know, all of this away.
Yeah.
And maybe all of this, well, because it's already a string, I don't have to do anything like this. Would this work?
Mhm. That's
Yep,
it.
let's try it. Haha, look at that. Furniture doesn't fit.
Yeah.
Right? Furniture doesn't fit. And if I take away the bouncy castle, or maybe add like, you know, if I
Make
do
it
control,
smaller size.
huh?
Why you wanna delete it?
No, I'm just gonna delete it for a second just so we can see the happy path again, like the path where, you know, it actually succeeds. So I'm gonna run it again and it should say furniture fits.
Mhm. But basically, if you have put it, but also make the size smaller, so maybe it fit as well.
That's true. That's see, you're too smart. You're too smart, Sally. So I'm gonna go up in here and say 50. I
Mhm.
think that would fit because 20, this is 40, 40, 50, it's 100. We still have space, right? Let's see. Let's run it again and see. There you go.
We wanna make it give a message that how much space is still left. So
Ooh, now we're getting interesting. Okay. So how do we do that? You know, if we're gonna be returning things, we can go in here with space left, and then I can go here and put the space that's left, which is available space, because that number keeps decreasing, right?
now I got.
Let's run it again. See, and now you're getting innovative. There you go. There's
Oh,
200 units of space left. I'm not
mm,
gonna say feet because there's no chair that's 20 feet. That's weird. But I'm just gonna say units of space.
mm, now I got it. Okay, interesting.
Right. So you see how easy. So tell me here. Here's the interesting thing. As someone who's just looking into this, what's problematic here to understand? And like I said to you, I'm learning just as much just by seeing, you know, this is a style of me trying to kind of explain a problem to people, right? We created the furniture. Here's my furniture. Here's a chair, a TV, and a bouncy castle. And then each of them have the exact same thing. So I basically said this is, oh, they're all furniture. And I'm basically defining that furniture type. So since they all are inheriting from that furniture, now I could just go and say, I can pass in here whatever furniture I want.
Mm.
Is there anything here? And we have like 4 minutes left. So is there anything here that you see
So
that,
pretty much everything clear. So something I wanna wish like you know room and room when you keep track. It's kind of hard to keep track, and maybe I would call it room one or something like that. When you put a class and then yeah something like it keeps me like okay that was class. This one is like object of that. But when it is room
ah,
for me, it's kind of it is me that is hard for keep tracking those.
no, you're right. Let's call it living room. Let's give it an actual proper name. Living room. What do you
Now
think?
it's much easier for me to keep tracking of the like furniture. I would call it furniture number one, furniture number two. So, and I know this is okay. That one class, that one is object. So
Hmm.
that's the part. But generally, for me, it's clear. And then I just want to know more about the parse. So I didn't no prompts. Well, can it go up, please?
Oh, the params in here? Yeah. So
So,
tomorrow we'll talk a little bit more about that. We'll talk about what does that mean because you could actually also just add a list in here.
mm-hmm,
It's the exact same thing. You could go and say, I want to pass in a list of furnitures
mm-hmm.
like this, and it won't change anything in your program. What's the difference? right? Why params is cooler, than a list? And when do we use a list and when do we use a param? I don't want you to worry too much about the syntax of the language as much as, basically we're gonna go over this anyway, but the one thing that I really want us to kind of look at is that how do we visualize a problem? We started with this simple problem in here. I basically went in and I said, "Hey, um, this is an investment. I need a program that will help me. If I am having a kind of three chairs and I'm inviting my friends, would that actually fit into my system or not? That problem that we're solving today, some people say, well, this is a hypothetical. Actually, that's not true. Decor engineers and people that basically furnish houses and hotels and stuff like that, this is top of mind for them. How do you solve for that problem? That's how basically, architects, people that build buildings and civil engineers and stuff like that, they look at a street or a city and they say, okay, we want to have facilities in here, we want to have bathrooms in here, we want to have all of these things in here, is this gonna fit? And they add in all these little rules in there. Like today, we just added one rule, which is that, if it's bigger than the space, that's it. But your program can grow exponentially more complex, the more you start adding in more rules and stuff like that. So, so this was it for today.
Thank you
You
so
know, uh so let's connect again tomorrow and let's see if we can take modeling and simulation a little bit further. By the end of this series, you'll be able, when you're writing code, you wouldn't even think about the code anymore. The thing that you're going to be thinking more about is, what problem I'm trying to solve and how I'm going to solve this problem in a way that's, test driven, properly, written properly. Like the code that we wrote today, it does solve the problem. But is this code that we wrote readable? Is it tested? If someone goes in and changes my code, how do I know that things broke? How do I know that, the more complex the system becomes, the more important that we protect it with tests so we know that nothing is going to break. This little code, see, it's all logic, Sally. You're basically going and saying, what's my space? And for every piece of furniture, make sure that if that piece of furniture, if there's a still available space in here, then go ahead and take away from that space. And then if there isn't, then just say it doesn't fit. And if there is, go ahead and say furniture fits with space left. I'm assuming you know this code off the top of your head, so you don't need it, right? That was a joke. Okay. All right.
No, of course I
Okay, I'm gonna send you this code. I'm actually gonna put it on something called Git Gist, and what Git Gist is basically a GitHub kind of thing that basically helps people share a quick snippet of code. That's all it does. So let me go up here on GitHub and there's something called Gist. Let's see if I can have a Gist import new Gist, and this is coding with Sally 001. Okay, and this is here modeling simulation 001. Here's here's the language in here. I'm just gonna go ahead. There used to be a place in here where you could, oh, if I do CS, does it? Yeah, there you go. So that's C sharp. And then I'm just gonna add the file. I don't want to create a secret gist. I want to create a public gist. That's my public gist. Delete this file, create a gist, and I'm gonna attach this uh, GitHub gist in the description of this video. Sally, thank you so very much. I hope this was useful to you. And let's connect tomorrow and let's do more. Okay?
Sounds
Cool.
good. Thank you so
Thank
much.
you very
Looking
much.
forward to that.
Yep. Take care. Thank you. Bye. Bye.